Our next speaker is Gogula. So he is a data analytics professional from 15 years experience as Microsoft MVP and on data platform from Sri Lanka. So yeah, Gogula, over to you.
Thanks so much. Good morning, everyone. Let me just quickly share my screen.
Yeah.
Hope you guys are enjoying the session so far.
Let me check the result chat part.
Asif, I think we just lost you. You're on mute.
Yeah. I think you can just share. I can see your slides. You can just.
Okay, so I can go ahead.
Yeah, I think. Hi everyone. So our next speaker is Gogula. He is a Microsoft MVP from Sri Lanka on data platform. He's over having more than 15 years experience in data industry. So yeah, over to you, Gogula.
Thanks, Asif. Good morning, everyone. This is Gogula from Sri Lanka. Today I'm going to talk to you about data modeling in Power BI, why it's important, and how we can build a good data model. So I work for a company called Fortune. I'm the lead architect there, where I design and architect BI and analytics software solutions. I also co-run the Sri Lankan data community. And welcome everyone to this specific data sessions. Moving on. This scenario here, you can see a typical reporting for analysis scenario is what I usually see when I go to visit my clients. Okay, so these clients are basically the business analyst, the financial analysts, the sales analysts, folk like that. So in a typical reporting for analysis scenario, what they do is they, on a daily basis or a weekly basis or on a monthly basis, they go to the different sources that they have for data, and they try to bring this data in together, do some analysis on top of that, and then report that or showcase that to the management or the board or the different stakeholders in various ways, so that these stakeholders can take decisions on the direction of the organization and what they need to do and what they stop doing. So that the data is very important. So it's these analysts who help out with this. Okay, so if you when you talk about Power BI, it's very important that you understand that Power BI is focused towards the analyst. Okay, now a lot of us as developers, as BI developers, we do get into Power BI a lot. But when we look at data analysis, we need to put on the hat of a business analyst and then start working from there, because you need to understand the business, and the business model has to, or the business has to be reflected in the data model or the business model that we are creating. So in this typical scenario that you see on the slide, okay, you have these various analysts. They go to the different sources. So usually they get the data from an Excel download, or save a report as an Excel file from the various systems that the data has to be taken out of. And then in certain cases, you also have the data which they don't have access to. So they usually go to the database administration or IT, and they request for that data. In a lot of cases, you don't get direct access. Okay, so you need to be quite good friends with the DBA or the tech team to get access to some of the data. In a lot of cases, this data is provided in the form of CSV files, and that's fine. To get started with, to build your models first up, it is fine that you don't have direct connectivity. As long as you get some sort of data in a proper form, it's good. And then what these analysts do is that they take this data, they mash up this data together, and they create various semantic models, or business models, you call them. Okay? And the models that they create is then converted into graphs and tables and put up on PowerPoint. And this PowerPoint is shared with the top management or the stakeholders. And then in certain cases, the stakeholders will have some questions. Now, when these PowerPoint reports are of course static, right? So when certain questions are asked from the analyst based on what is shown on the PowerPoint, it goes back to the analyst, and they have to now change the Excel a little bit, answer the questions in the form of another graph probably, or another table, copy that onto PowerPoint and then send it back. Now this entire process takes a while, and it is not an automated process. And in a lot of cases, if you look at the actual Excel reports, the analysis of the data looks a lot like this. And more or less, this is what is copied and pasted onto PowerPoint. And sometimes on top of this, certain graphs are created, and those graphs are copied and pasted. Now, if you look at what you see on the screen here, it is a typical pivoted report. So we have, for example, the products on the left, you have the countries and the current and the previous year and the growth here, and we have the data in the middle. Now, when you look at something like this, it's very difficult to look and understand what's going on with the business. Of course, you see these little spots where it shows green, where the growth is good for a certain product, but beyond that, at a higher level, it's quite hard to understand. Even getting a trend, seeing how well it has performed against the last year, it's quite hard. Okay. Then we have another report here again, where you have the countries, the products, and again the quantity sold, stuff like this. Again, looking at it at a glance, it's very hard to understand what's going on with the business unless you look deeply into the data. You keep concentrating and trying to figure out what's going on. I mean, it takes quite a while. Okay, so that's why sometimes you put some graphs on top of this, but then again, when you're doing it on Excel, you have to copy up the graphs and put it on PowerPoint, and that's the usual scenario that I have seen when it comes to business reporting or reporting for analysis in various organizations and clients that I put help. Right. So then, when Power BI comes into the picture, okay, now Power BI has grown quite, has become quite popular. Okay, there are a lot of organizations that use Power BI. So even when I go to help out these clients, I can see that they use Power BI quite a lot. But the thing is, in the majority of the cases, Power BI is used as a replacement for PowerPoint. Okay, so they have heard about good things that Power BI can give, but what they actually do is they replace PowerPoint with Power BI. They just look at it as a visualization tool. Right. So let's see. So what of the main or major issue that I've seen is this particular file, which is a this particular report, which is a pivoted report, is what is usually used as the source of the data model. Right. So you have this little pivoted table here with products on the left and the years and the values on the right, on the top as a pivot, and this is what is taken as a source. And then when you take it as a source into one of these reports which they're building, okay, this is what it looks like. Let me just quickly open up and show you what it looks like. Okay, now here, when you pull the same thing into Power BI, it looks like this. Okay, you have to do a little bit of cleansing, but what happens is you get a list of values like the February value, the February quantity, the January quantity, January value, June quantity, and so forth. You have each of the values that are measured coming up as columns. Now, when you take this and try to put it on a report, what you see on the report comes up like this. So you have each month's quantity like this. Okay, now just look at it on the right hand side. Right, we have all of these different quantities and values of the various months. The type of analysis that you can do with this kind of a model that you are creating by default is that there is not much flexibility in here. Example, now let's say I bring in the January value quantity, sorry, and the February quantity, and now you need to create, you need to find out the difference or the growth between from January to February. You'll have to create a measure. Now you can get that measure. The problem is, now if I want to do the same thing with February and March, I'll have to create another measure. And I have to keep on creating measures like this, which is not quite that effective. And again, the type of analysis that I can do is very much limited when you just bring a pivoted table straight into Power BI. But this is what a lot of analysts do when they first try out Power BI, and now that quite limits their ability to report. Okay. So let's see how we can do this better, how we can do this modeling in a much better way. Okay, that's what's going to be in my demo. So I will talk about what happens when Power BI comes into the picture and what you should not do and what you should ideally be doing, why and how. Okay, so let me first quickly put up an empty Power BI window here. I'm on Power BI desktop. The first thing that you need to do is try to understand what data you're going to bring in. This time we have this report here, which has the product and subcategory, the product and the style, and certain information about the product. You have the various months. You have two values that you want to measure: the quantity of the products which are sold and the value of the products that have been sold, or the sale. Okay. First up, try to look for a source which is not pivoted. Try to go towards the actual source, the raw source, as much as possible. When you want to get data for this, try not to use a processed table. This, what you see here, is a processed table. I have Pradeep's hand up. Pradeep, do you have a question? But not. Okay. So
sorry, I missed it.
Okay, no worries, man. No worries. So like I was saying, try not to use a pivoted table for a source. Try to go to the source of all of these. Now, in a lot of cases on Excel, you will have a set of data brought in, the imported data or the data that was downloaded from the system, which looks like this. Now, this is a better source than your pivoted table. Or even better, if you can go to the actual source system, talk to the owner and get the data in the form of some files or connectivity to the database. Okay, so let me start with that. Let me start with going to the data source itself. But in this case, I am a business analyst and I am not usually trusted with direct connectivity to the database. Therefore, I will get some data in the form of CSV files. So what you see here on my screen are some CSV files. So I have got files for the product, the category, the sales header, the sales detail, and so forth. Okay, so I'm going to tap into this data files and bring in the data into Power BI. Okay, cool. Let me just copy this location. Let me go and get some data. It's going to be text data, and I will just quickly paste that there. And I'm going to pull out the sales order header information, which has the first bit of sales. So when that comes in, the first thing that you should be doing is not load it directly into Power BI, but do a little transformation. You'll have to do some cleansing almost every time. Okay. Now we know that the data that we want to analyze is the quantity and the sales. And on the sales header, as the business analyst who understands the business knows that I don't have the quantity on the sales header, but it is there in the sales detail. But before going there, let me just pull out some columns that I would need to analyze by. So I know I need to do analysis on the orders. So the order date is a good thing. And I also look at other information that I might need. For example, the customer's ID, the salesperson ID, because these are the links that I have to the various dimensions that I want to analyze by. So the customer ID and the salesperson ID. I will also take the ship to address ID so that I know where these items are being shipped to, so that I can analyze by that as well. I would not take the subtotal, but rather I would use the quantity and the unit price in the sales detail to calculate the subtotal. And also, I have nothing else from this one, just these few. And I know that I have a sales order number, which I might need to count the different sales. And I will remove other columns. So what I have here is the date, the customer ID, salesperson ID, the address it's been shipped to, and the sales order number. Okay. And one more thing that I forgot is I need to have the sales order ID as well, because I need to link to the detail table. Okay, so once I got this, let me now go and pull in data from the sales order detail table, which is another table which has the detailed information. So I will click on OK so that I can now pick the columns that I want from here. So I will click on choose columns up here, and I will choose the sales order ID so that I can link with the order header, the quantity, the unit price, and the product ID, because I want to know which product it is. Right? And the rest of them I'll just leave out. So it's always a good idea to keep only the columns that you actually need for analysis and leave out the rest, so that there's less clutter and also less data brought in.
Yang sama lagi.
And then we know that sales order header and sales order detail are part of one thing, which is the sales order. So what I will do now is I'll try to join both these tables, link them up so that I have one table. Okay, so instead of clicking on merge queries, I will click on merge queries as new, so that I'll have a new table, a completely new table, where I have joining or merging the sales order ID with the sales order detail table. Okay, and when I do this into the sales order header, I will get the sales order detail merged as a table. Okay, just embedded as a table. So what I will do now is choose the columns I want, which is everything except for sales order ID, because I already have sales order ID here. So I bring in now the product ID, the sales, the unit price, and the quantity. Okay, and another thing what we usually forget to do or don't bother about is the name. The naming conventions. Naming conventions in Power BI in a semantic model or a data model that is going to be sent to the business users has to be named appropriately so that they can understand what's going on here and what each columns mean. So which means even if there are spaces, it is always good, it's always nice to have it named in a way that an end user can easily understand. Okay, so I'll just call this order quantity. And not have any cryptic names and not have shortened names. It's always good to have names that are full and unit price. So what I'm doing here is I am naming all these columns which should be seen by the end user in a proper way, in proper case, with a space in between, so it is very lifelike. But the ID columns, they are going to be hidden in the when I put them into the model, so I'm just leaving them as it is for now. Okay, so naming is quite important. Now, once these data has been brought into one table, I will name this table as sales. Okay, and then I will disable load on the header and the detail table, because I no longer need them to be used for analysis, because the data in those two have been brought into sales. Right. So now, since I have the sales information here, I need to have more tables through which, or more tables which will help me analyze the data that I have here. So now I have the order quantity, which I'm going to analyze. I need to have the order value, which is a product of these two columns. So what I'll do now is, before I bring in any more tables, quickly add a custom column. I can do it later on, but I'll do it here itself. I'll just call this value, and I will do a quick calculation here. The order quantity multiplied by the unit price, so that's the value, and have a sales value here. Okay, so I'll just change this into a fixed decimal. Okay, so this value and this quantity are the things that I am going to measure. And what I am going to measure by are the columns, are what are going to be brought in from other tables. Okay, I will also get rid of this unit price and the yeah, I'll just get the unit price for now. Okay, so now I'm going to bring into this more data, which is going to be the product. I also noticed that along with the product, there is another table called product subcategory, and also a table called product category. So now in my business analysis head, it's working. My head is working. I start remembering that subcategory again is part of the product. Category is part of product. So I bring them in as well. Sorry. So I've got 3 tables that are related to product. And what I'm going to do now is merge all of these together. So I'll quickly merge product with the product subcategory on the subcategory column. Okay, so the data types are different. So I had to quickly make a change in the product subcategory, which here is a text. They all became text because they have been brought in saved as CSV files. On subcategory, it's fine. So I will now merge these 2 tables, the product table on the product subcategory ID and the subcategory table on subcategory ID. You can see only some columns have matched because there are some nulls there, so that's fine. And when I expand this, I'm going to bring in the name of the subcategory and the category ID because I need to now link with the category column of the category table, right? So I will merge this table now on the product category ID with the product category table on the category ID of that table and bring that information in here as well. And here I will just bring in the category name. Okay, so now I have quite a lot of columns here. I am going to choose the columns I want. So it's going to be the product ID, the product name, maybe the color of the product, the style of the product, and of course the subcategory name and the category name. So I'm only bringing in a few columns like you can see here: ID, name, color, style, category, subcategory name, and the category name. Okay, so now, like I did earlier, I'm going to rename this as subcategory and this one as category so that I'm going to make it very business friendly. I see that I have a lot of null values, so I can replace these null values with something understandable. It's always good to have no null values at all. So you need to somehow cleanse this data to have something acceptable there. So what I am doing here is I'm just replacing null values with not available. There are different values that you can use like unknown and any other value that suits your business. Okay, I'll just leave the rest of them as they are. And I will now disable the load of subcategory and category, and I will bring in only the category, only the product. And so now I have the sales and the product. Now similarly, if I go back to my sales, I also have the ship to address, the salesperson ID and the customer ID. So similarly, I can bring in the customer table, the country, province and city tables, and I can also bring the salesperson. Okay. So for now, I will not do that. Just one more other thing. Order date. Now, order date does not has only the dates in here, right? But when you do analysis, you will want to do the analysis on the month, the quarter, the year, and you also might want to do certain things called time intelligence, where you might want to calculate last year's sales value. And then once you calculate last year's sales value, you might want to do a year to date of the sales value. Now, in order to do all those time intelligence functions, you need to have an unbroken list of dates. Now, that unbroken list of dates cannot come from this column because this is the order date column. There can be dates where orders have not been done or made. Okay, so it's always good to bring in a set of dates from somewhere else. The thing is, here all the information is brought from the sales database. The sales database may not have a calendar table. So what you can do is you can there are so much of scripts out there on the internet. You can use one of them. So this is a Razor's script, which is freely available on the internet. So I will copy this code. Okay, the link will be there on my PowerPoint. And what I will do is I will go into new source, and I will open a blank query. And I go to advanced and I place this script in here. So this is a script which generates a list of dates from the beginning of a particular year to the end of another year. Okay. So here in the code, you can see that the beginning year is 2018 and the end year is 2021. I will alter that to 2014, I think, to 2020. So now what it will do is it will generate dates from 2014 January 1st until the end of 2020. Okay. And what's cool about this script is it has lots of different attributes of this date. It has the start month, the day name, the week, the year, and also has, when you go to the end, financial year columns as well, or the fiscal columns as well, so that you can create, you can do analysis on the fiscal year as well. I will call this table calendar. So it goes to show that you can bring in data from source systems, and you can also generate your own data. Okay, so now I'm not going to bring in customer and others. Let me just quickly click on close and apply. And it will pull in this data into my Power BI model. Right, so now once it brings in, okay, you can see that I have built my or designed my tables to have the sales information, or a table which has the information which I want to measure. So the table which has the values that I want to measure is called the fact table. So the sales is the fact table, which has two facts. One is the value and the other one is the order quantity. Apart from that, it has IDs which are links to other tables through which I will do my analysis by, right? The filtering, the slicing and dicing and things like that. Okay, and product ID has automatically linked. I will also link my date to the order date column, and I will have something like this. Okay. Let me just upgrade my model to a new set of features that Power BI offers, so so that my modeling is much more easier. So now what I will do next, okay, is quite important as well, though they may seem trivial. Okay, now first up, I will only make sure that the columns of my fact columns, order quantity and value, are the ones that can be aggregated. So by default, they are already aggregated with the sum function. But the rest of these things will not need to be aggregated, like the sales order ID. So what I will do is I will click on sales order ID and go to advanced, and I will say no summarization. Same for ship to address customer ID. Again, I'll select both of those, and I will specify them as not to have an aggregation. And the next thing is, all these ID columns are not going to be analyzed by, okay? So they are just IDs from the database. So what I will do is I just hide all these IDs. Okay, so let me just select all the ID columns, and even the order date, right? Because the order date acts as an ID, and we have the order date, we have the dates here in the calendar, so I can hide all of these. Okay, so now what I will see when I go to the report is just the order quantity and the value columns. Okay, now the idea here is you try to reduce the number of columns that the end user sees or the analyst sees, so that okay, we got two more questions. Sanjeev, do you have a question? Or what's the mistake?
Gogula, thank you very
Yes.
much for taking time on a Saturday, man. It's a fabulous conversation.
Sure.
Real quick one, when you go back to Power Query really quickly and you looked at the date table, have a question on that, So, the transactions keep happening, right? I mean, when you refresh like tomorrow, let us say this information is actually coming from your ERP system, and the dates will get updated, right? Based on the transactions that have happened.
Yeah.
Would it be okay to construct the date table from this order table directly using mQuery, so that the dates will, the contiguous dates, the first date and the last date will automatically get updated?
That's a good question, Sanjeev. Thanks for that. So Sanjeev's question is, since transactions keep occurring on a daily basis, and since my calendar table just stops at the end of 2020, what are we going? Can't we use a better way of automatically picking up the last end date of the transaction? You could do something like that. It may require a little bit. You might require a bunch of merging to be done. For example, you can go into the advanced, sorry, not the advanced editor. You can, what you could do is probably get the last date of sales. So you can have a new query where you can get the last order date, the maximum order date, and then merge that in one way, in some way with calendar, and do that here. Or another way would be to use, instead of using 2020 up here, we can use the today function and go to the last day of the year, so that you will have dates filled up right until the end of the year. So this example was just, yeah. Okay, so you can come up with various ways. Thanks, Venkat, for the question, though. So you can come up with the various ways to which where you can automate it, automate the list of dates. And the best way I feel is to have full set of dates for at least the current year. So again, that can be automated in various ways using Power Query.
Super, Gogula. Thank you very much, sir.
No problem. So when we get back here, so we have hidden most of the columns that need not be shown. And then here when it comes to product, again, the product ID is not necessary to be visible because nobody's going to be analyzing product by the product ID. And similarly, when it comes to this list of dates, okay, there are so many of these columns here which have been automatically aggregated by Power BI. So what I'm going to do there is select all of those and not aggregate them as well. So get all done. Okay. Okay, so now if I go to the reporting page, you can see on the right-hand side that there are these three tables. And most importantly, sales order has only the sales quantity and the value and the sales order number. So this makes it much more clearer for the business user to create their reports. And see, the clutter of the IDs have been all taken out here. Okay. Another thing that we can do next is to create some hierarchies so that analysis can be done a little bit more easily. Okay, so I can right click here and create a hierarchy on the category because category is always at the top. And then I can start adding columns to that hierarchy. Okay, so here I create my hierarchy. And I can change, I can rename some of these columns just to make it a little bit, tad bit more user-friendly again. Okay. And then once these are available on my hierarchy, I can even go and hide the category and the subcategory and the name. Okay. Now when I go back to my report model, you will see that my category of products are there. Okay, and then I have the rest of the attributes here. And again, it makes it much more a cleaner semantic model. And I can also rename this as products. The hierarchy, I'll call it products, and so forth. Okay. You can also create a hierarchy in calendar. You can create multiple hierarchies, such as the calendar hierarchy and the financial calendar hierarchy, and so forth. Okay. Now, once this is all done, okay, what you need to additionally do is, now the two columns that I'm going to use for measuring is order quantity and value. Okay. But then you would also want to do other types of analysis, such as, like I said, time intelligence based ones, where you want to calculate last year's sales and so forth. Okay. So the next step that you need to do is create you need to create a table which will hold something called measures. Now, order quantity and value, which are facts, they are local to the sales table. Okay, but measures are calculations that are global. They sit on top of all of these tables so that they can be used across the model for your analysis. Okay, so let me quickly show you how you can do that. Okay. So before I do that, let me quickly show you a model which I've pre-built here, which brings in. This is the same thing that I've built. Let's hide this one away for now. Now here, apart from the two that I have created, I have brought in geography and salesperson, similar to the way I did my demo. Okay, so I have all of this here. And then what you would do is you would go and create a new table called metrics. You can call it whatever you like, but I create a simple table like this using, I just give a name for it. I call it metrics because it's going to store all my measures and stuff. And I will just say 0. So what it will do is it will create a table with a column, default column called ID and 0. I will hide that column. It's hidden. And then I start creating the various measures on top of that. Okay, right. So that is what I have done here. I have created various measures that you can see. So the rule of thumb is, first off, create some base measures. Base measures are nothing but a sum that you put on top of the facts. So order value was a fact, so I created a base measure on top of that with just a sum called sales value. And then on top of order quantity, I created one called order quantity. And then using these two, I can now create more measures such as this one, sales quantity last year. So here what I'm doing is I'm calculating the sales quantity measure for the same period of last year, and what am I supplying as a parameter? An unbroken list of dates, which is coming from the calendar year. So that will give me last year's sales quantity. Okay, similarly, I have the last year's sales value. Then I will create another measure called growth using sales value and sales value last year. So what I'm doing is I'm subtracting sales value last year from sales value, and I'm dividing that by sales value last year to get a percentage of growth. So similarly, you can create all sorts of measures if you get your data model over here correctly. And this data model here is called a star schema. Why a star schema? Because we have the fact information in the middle and we have the dimensions around it. Okay, now this concept of star schema comes from data warehousing called the dimensional model, and that is what has been adopted here. So if you can make whatever data that you have into a model such as this, and that is your number one win when you are performing a business analysis, because a model such as this will provide you with a very flexible means of doing analysis. It is nothing much, quite simple. Just design your model so that it will have a bunch of columns which you want to measure, such as order quantity, order value, and then a bunch of columns which will link you to the other tables by which you will do your analysis. These tables are called dimension tables. Okay, so when you start creating your dimension tables, you have to make sure that you have the ID to link back to the fact table, and then you will put in only the columns that you can analyze by. Okay, there's no point in bringing columns such as the modified date, the creator date, and the user created, and things like that. Okay. And then once you bring them in and have this kind of a design, if these columns are not linked, or if these tables are not linked, just link them by dragging and dropping, and you get this. Okay. And the next step is to create some business rules and business to apply a business layer on top. So that would be creating a hierarchies based on the business usage, that's on the various columns, even on various tables, and also on the calendar table. And then if you have something like geography, you can apply some categorization. For example, if you look at geography here, you can see that city, country, postal code, they all have a globe symbol. That is because if I open up these properties and I select city, I have applied, if I go to advanced, a data category called city. So these are categorizations available within Power BI, which you can apply on top of certain columns so that now Power BI understands that this particular column is a city column. So by doing that, when you do any analysis on a map or something geographical, Power BI will be able to properly link or identify that it is a city and map it on the map visuals much more effectively. Similarly, there are a few other types of categorizations also. Ensure that if you have certain columns that can be categorized, please categorize them. Okay. And then, of course, you need to hide all those columns that you don't want being visible to the end user so that the model is much more cleaner. And then, of course, you need to create this separate table, which is a good practice to have. Instead of creating the measures, now these measures can be created on any of these tables. But as a good practice, what I do is I create all of the measures on a separate table. Okay, I create a temporary calculator table with a hidden column, then I start adding all my measures to this. And then if these measures grow out of hand, if there are too many measures, of course, you can select these measures and put them into folders. You can have a display folder where you can have something like this, quantity. So I am putting in some of these measures, the sales quantity related measures, into a folder called quantity, and the sales value into a table called value. So I'm just categorizing these various measures like this. So now when you go into the report, sorry, it's a very nice looking report, I'll come back to that later. You will see that the measures have been categorized. So we have, let's say, a whole bunch of them, like 20 to 30 different measures. It's good to have them all categorized into folders. And if you have very large dimension tables such as these, even these can be categorized into folders. Okay. Remember, you can still have measures inside the other tables, but as a good practice, if you have all of them in one place here, it will be easier for an end user to use them. Okay. So now when we have a flexible model such as this, then your analysis can be done in any way or in lots of different ways as possible. It will not be just limited to a pivoted report or a pivoted table. Okay. So it's all a matter of, and then it's all a matter of just selecting the measures that you want, and then using the dimensions that you want to analyze them by slicing and dicing. Okay, so bring your data model to a state where you have a bunch of metrics that can be used by the business and a bunch of tables by which they can analyze these various metrics. Okay. And you will also notice that the sales table, which is a fact table, has also now become converted into a sort of a dimension table, because the order quantity and the order value again have been hidden, because I don't have any use for them anymore, because now I have my measures here. Okay, so if you come to a state such as this, okay, then it makes it very, very easy to do all sorts of analysis and reporting, and not just getting stuck and restricted by a data model which you built on top of a pivoted table. Okay. Now, what I said is sometimes easier said than done, because here I have used more straightforward sources. But sometimes, if you don't have access to the actual sources like these multiple files that I had, and if you only have something like this that you have brought in, a flat table, that is also okay. You can do the same thing by pulling this into Power BI and then keep splitting them out, because here I can see that I have these three: product category, subcategory, product, which will make up the product dimension table. I can see that I have country, the country code, and the state, which can make up a sales table. So what you would do, or what I would do, is bring them all into one table and then start splitting them out from that table into small tables. Or if you want to have a quick fix or a quick solution for that, you can still bring them all into one table like this, and then try to make it and try to clean it up so that you will have only something like this when you go into the report. Look at this. There's calendar hierarchy, there's geography hierarchy, there's a product hierarchy. Then you have certain other columns here like the sales order number and so forth. Some of them can still be hidden, and you'll have a folder with the measures separated out here. Okay. The only issue here is that since there is no calendar table with an unbroken list of dates, you will not be able to do much with time intelligence, but this is a good start. Okay. So even if you have a flat table here, this is good to start with, but it's better if you can split these out into separate tables. For example, if I go in here into my Power Query, I have this one sales table here, right? So what I can do is right click on this one, and I can say reference and create or create a reference actually to the sales table. I'll call this product. Okay. And then I will choose only the columns that I want, which would be product, subcategory, category, the style, and there is no color here. Yep, just these. Okay, so what I did was use the same table here. I split it off into a reference table. Now I can use this one in here when I bring it in. So similarly, if I can split out the geography and the salesperson information, I can still finally end up with a similar table to a similar model to what I previously created. Okay, and then you can hide off things, you can link it up, and you will get a star schema very similar to the one that I created. Okay, so if you're just bringing in data from a flat file or a flat set of records, go with this approach and then try splitting them out. Okay. And then a little bit more of an advanced thing. In my sources, I have an annual targets. So this is coming from a separate source and not from the database. So this has a list of dates, just the categories, not the products actually, but at a higher level, at a higher granularity, the categories and a target value. So now if I bring that in into my Power BI, you can create a model such as this. Here, if you look at it, the same model, but additionally, I have the sales targets brought in here, and sales targets linked to only calendar, and here to the category. Okay. Now, if you're doing it in the traditional way with the data warehouse, you might have to split this table into a category table and a product table and have a snowflake kind of a schema. But Power BI allows you to have something called many-to-many relationships. It is not recommended in all scenarios, but in this scenario, it works quite well. So if I show you the relationship, it is not the type of relationship the rest of these tables have, but it is a many-to-many relationship where I specify that the product filters sales targets. So the filtration still happens, but I have linked it at a higher level, at a higher granularity. So now this is two star schema. So I have one here, the sales, and a simple one, a smaller one here with the sales targets. So when you keep adding more tables, you will notice that you will not just have one fact table, but you might have multiple fact tables, and you have to bring them all together and reuse the dimension tables across these. Okay. So by doing things like by building semantic model like this, analysis can be easily done. More analysis can be done because at the model level, all of these tables are connected. So you can have things like cross filtering easily working across the report. Okay. So it actually works magic when you actually design the model the right way. So since my time is up, let me just quickly get back to my slide. So this is a star schema like what you saw. Try to bring your data into a model that looks like this or similar to this. It can get a little bit complex like this. You may have more and more fact tables coming in here. Also have a separate metrics table, which will be easier for end users to use and keeps organization easy, organizing your model easier and better. And these are some of the rules of thumb that are used when modeling. Okay, when you are preparing data, get closer to the source as possible. Okay, so that is, if you can get to the database itself, that's the best. If not, get some files dumped out of that. If not, have a flat file with all the information as much as possible. Then you design. You first design it on a piece of paper as to what is going to be your fact table, what are going to be your dimension tables, and then come up with your star schema. Try to break down into dimension tables and fact tables, like I said. So that's a star schema again. Always try to use a calendar table. It can be a static calendar table to start off with, but then it's good to have it automated, like Sanjay pointed out. Make sure all of these tables are related. Use naming conventions. If you notice, my semantic model has naming conventions which are very business friendly. I have put spaces in between names. Each name starts with a capital letter. There are no cryptic names in there. That is quite important, even though it seems like a small thing and that it can be neglected. Please don't neglect it, okay? Because it's the end users who are going to see it. And again, hide IDs on your model because nobody's going to analyze based on those. Again, naming conventions are important even on the business layer. Create hierarchies to make analysis easier. Hide all those unnecessary columns. Create measures. Forget the facts. Okay, once you keep your create facts, and then on top of those facts, create the measures and hide those facts. Sanjeev has another question. Go ahead, Sanjeev.
Hey, Google, this is fabulous information, yeah. So if it's since it's only because it's you and Dinesh, I'm gonna ask this question, okay? If it was anyone else, I would not ask this question, okay? So here's the one. So this star schema, like Karthik was mentioning, is an artifact of history, right? Basically, we've been doing star schema ever since man crawled out of the caves, basically. So in this new world of like schema at the time of query, right? That's what Cosmos DB does. How does that apply to this one? Can I make a schema at the time of query?
At the time of querying, yes, we can. So even what I've done here is it's sort of creating the schema at time of querying from the files. Okay. So if it's going to be a database or even a Cosmos DB, when you bring in the data into a Power Query, either you do it at the source side, okay, which will be better because the database has more processing power, or you can just, or if you are not as a business user or as a business analyst, if you are not versed with the SQLs or the comparatively lower level coding language.
Sorry, Google, let me make it simple. Can I actually bring JSON files here and then make schema literally on demand and then hook it up to structured tables?
Yeah, I think you can. I think JSON files are supported. Yes, you can bring them in, and using Power Query, you can just convert it.
Exactly, right? So that will be what, equivalent to what Karthik was mentioning, is that we can bring in the new world along with, how do you say, data which is in older world, correct? When I say older world, star schema, but the thing is, you're bringing in, semi-structured data, and then, things like, Twitter, which are unstructured data as well into this. Thank you very much. The one last question is, and this, we see this all the time, is when would you use transformations in Power Query versus use, when would you use, how do you say, transformations in Power Query versus using DAX versus using calculated columns and tables?
Okay, so I would use calculations in DAX so that the processing of the files can happen before it comes to the end user. Okay, so in a lot of cases, the model is processed in the nights or just once a day or twice a day, things like that. So if you can leave the processing, so if you can put everything to that processing, that would be the first step that I would do, so that that is no processing or time taken when the analysis is being done, and because these DAX calculations happen on the fly.
Excellent, excellent, man.
Yeah.
Excellent. Thank you very much. Huh? Yeah.
Yeah, no problem.
Yeah, Gogula, go ahead. No issue. Okay, go ahead.
So and finally, say no to pivot table sources. If your source is a pivot table, as a business analyst, don't don't use pivot tables as a source. So make Power BI work for you the right way, and not make Power BI just these visualization tool. And thank you so much. If there are more questions, please ask me. And also, please rate my session by scanning the QR code that you see on your screen, please.
Hi guys, if you have any questions, you can use the raise hand feature. So, and we can unmute yourself to ask the questions. Okay, I think thanks, Gogula. Really wonderful session, and it's like, yeah, it's really nice. I think Power BI. Okay, so we'll hand over to our next speaker, John. Let me share my slide. So hi guys, we have a next speaker lined up. Please provide your feedback on means this on Bitly link, or either you can scan the QR code. So let me just put on so you can provide a feedback. And about the next speaker, so John is going to talk on the topic of developing Azure machine learning solutions locally. And John is a Microsoft MVP on data platform from Philippines, and he is also means data engineer at IBM. So yeah, so please have to provide a feedback first for Gogula. Hi John, you are there?
Yeah. Can you hear me?
Yeah, I can.
Hello.
Yeah, just
Great.
wait for a few minutes so at least everyone can provide a feedback, and then you can start. Or
Okay.
maybe you can share your slides.